All right. So we'll hand it off to Gabrielle to hear all about the NSF Pose workshop.
Thank you, Tim. Very excited to be here. So I'm going to report on a workshop that we did a few weeks ago, about a month ago, actually, at the University of Washington. I have many slides, so I'm going to share my screen. Let me know if you can see this. What do you see? Do you see uh, slides? Yes. Okay,
Looks
cool.
good.
Excellent. So yes, I'm Gabrielle. I'm a PhD student at the University of Washington in the Department of Human-Centered Design and Engineering. I am part of the Machine Agency Lab, led by Nadia Peak. And so the work we do in the lab is to harness the precision of machines for the creativity of individuals. That's our tagline. And so whether it's in the arts, engineering, or the sciences, so this research program involves a wide range of projects, from building interactive digital fabrication systems to developing systems that support lab automation workflows. It also involves talking to people sometimes that use these tools and then kind of use the learnings from those conversations to inform the design of future systems. So, as an example, this is a project I worked on a few years ago where we interviewed 13 professionals who use computer-controlled machines. So some degree of automation in their workflow. And their work is, as you can see, not so much science focused, but much more sort of craft based. So it's very there. These people are making very expressive and unique um, things that rely on the precision of machines. So whether it's cups, lamps, tables, vases, textiles, and so they kind of like explore how machines um, can sort of widen aesthetic spaces when it comes to these objects. Um, More recently, the lab has been developing the Science Jubilee platform. So this is a Jubilee. So Jubilee is an open source multi-tool extensible motion platform that was developed by a former student in the lab, Sonia Vasquez, and is now used by a lot of people for various applications, including lab automation. And I want to shout out Madeline, Madeline Wolf's, who's here, founder of the Automated Lab, who made these extremely cute figures of Jubilee. I think these should be the new official Jubilee figures. And also wrote a really great piece on the Science Jubilee platform, which you can read on the automatedlab.com website. I think the link is already in the chat. And plus the art is amazing on the lab, and the content is amazing on the automated lab. Um, okay, so as a research lab, as I said, we make things, we talk to people, we then write papers about what we made and what we talked about and with who, and the outcomes of that. But sometimes we also organize workshops. And so today I'm going to talk about the second iteration of the POSE, or Pathways to Open Source Hardware for Lab Automation workshop, which took place about a month ago, which is a NSF funded project. And so I'm going to talk about what we did, what people talked about, and perhaps kind of try and leave you with one idea for where to go with what we learned from the workshop. Um, and so the point I'm going to try to impress on you all through this talk is that when we think of lab automation, we often think of this. So the tools, the tech, what do we need? What software, hardware, data pipelines will get us there. And developing these open source tools and lower barriers to entry when it comes to lab automation is, of course, very important. But it can also sometimes risk overlooking something essential, which the workshop was mainly designed for, which is community. So getting people together, making things together, talking together, which this group right here is a really great example of. And so everything we made and talked about in this workshop was ultimately in service of just getting people together and sharing stories and experiences. And so this is the outline for the talk today. I'm going to touch briefly on the workshop, um, then what we did, then what we talked about. We had four sort of, moderated discussions throughout the workshop, and then talk about like where do we go from there. And if at any point people have questions, feel free to stop me. I'll gladly answer any questions. So the workshop was held on April 13 to 13 to 15. We had about 30 people attend this event. It was at the University of Washington in the HCDE, or Human Centered Design and Engineering building, where our lab is based. And so, yes, the goal was really to bring together engineers and scientists to collaborate on open source lab automation. And the workshop was sort of organized around the Science Jubilee platform. So we had 6 machines, um, uh, each with a set of tools such as like syringes, pipettes, spectrometers, cameras. One machine had 3D printing heads. And the machines were sort of set up to be controlled from Jupyter notebooks that had been prepared um, mainly by Blair and Dan Lee here today as modular notebooks to design and run experiments. So this is an example of the Getting Started notebook, which was just a notebook to sort of move the machine around. We had participants from a little all over, mostly the US. As you can see, a lot of people from the University of Washington, from material sciences, mechanical engineering, um, chemical engineering, computer science. We had a few people from elsewhere in the US. Uh, we had people from Canada, and we had 2 people from France. Our international group. And we had 10 organizers, including Tim here. Tim was an organizer for this workshop. And again, so a lot of people in the lab were present today, and other people from other US and Canadian institutions. And the workshop was sort of divided into two main components. There was a hackathon component, and in between each hackathon session, we had discussions. I'm sorry, Tim, this was really the best picture we had about the discussion sessions. They weren't like super well documented visually. So yes, here we have Tim and Bob Lister, who made very good use of the design lab infrastructure. So they took notes on a table and shared it generously with the rest of the group. But I'm going to start talking about the hackathon portion of the workshop. So this is an image of our lab. And people made all sorts of really cool things with all these jubilees that you can see. So one of them was liquid handling and mixing with a robot arm. So made by Sterling Beard from the Accelerate Consortium at University of Toronto, Tim and Nadia. And I mean, I don't know if you want to say something about it. Tim, there was a video also that was shared about the whole operation, but if there's something you want to add, please feel free since you were there.
I think only that it's a wonderful demonstration of how the details really matter in an orchestrated automated setup. The sort of narrative here that we were saying was, oh, let's use the liquid handling robot to mix some amount of liquid in and then let's have the arm come in and invert and to sort of simulate maybe you need to very gently mix with a low shear. Um, and I think if you watch the video, you will notice all of the times that I had to intervene, including capping, because capping takes, you need a device that does that, and we didn't have one, and we wanted to do the whole thing in, over just this 2 day period. So yeah, it did work, and I think it was a success. But I think definitely shows the limitations of why you need more than just a 2 day hackathon to put together a real automated system. Oh, and I suppose also this robot was great. I forget the actual cost Sterling quoted. He brought it. It was a few $100s, but it also shows you that you kind of get what you pay for as far as robustness and stability. You can kind of see it wiggle a lot, and it makes some interesting choices as it tries to move to the correct poses. Oh, there it goes.
Yeah, with very, very slow mixing. But I don't know, maybe that was actually it's less slow than I remembered. It's quite delicate.
Like many automation videos, I think it would benefit from being played at 5x speed or something.
Cool, thank you. So that's yes, there it is. Yay. Yeah, so that's one of the things that happened during the workshop. Another thing that people made was a print and play sample holder. So that was made by Matt Reich from University of British Columbia in Canada, Aliénor Lalou from the Sony Labs in Paris, and Fabrice Dessely from University of Aix-Marseille. And so what they did was print and place a sample holder and then place the other holder for the two reference solutions to mix, and then fill the sampler using a syringe and take measurements. And because Jubilee is a multi-tool platform, that was kind of all happening in one single workflow. So that was cool. Um, Other cool things that people made. I guess this is maybe less Jubilee specific. I'm not exactly sure how the Jubilee was involved, but droplet magic. So this is sort of like droplet, like contactless mixing using ultrasounds. And that project was put together by Peter Bocage from the National Institute of Standards and Technology, Keith Brown at Boston University, Joshua Smith at the UW, and Jared Nakahara, who is a student of Josh. And I think this little machine, so they had this little machine here that uses uh, ultrasounds, like ultrasonic levitation for contactless manipulation. And they brought it and put it in a Jubilee and used it to, yeah, this is a link to their paper on contactless manipulation of millimeter scale objects via ultrasonic levitation. And so they used it to levitate little drops and mix them with color. Um, yeah, so that was pretty cool. One thing that is interesting is that the longer these little drops levitate, the ultrasounds basically dry out the water, so eventually there's just like a little bit of pigment left suspended in the air, which was quite interesting. Other things that people made here, well plate illuminator by Nadia, which she made for another team made out of Clara Tamura from the UW, Nikki Nemerson from Boston University, Madeline Wolf from the Automated Lab, and Eleftheria Rumeli, who also at the UW in Material Sciences. Um, Nadia said it took her a whole 15 minutes to make it, and it was put to very good use by this team, who then used it, among other things, to measure biomaterials. And so Eleftheria had brought different biomaterials, which they had mixed and then measured using a spectrometer, which was one of the tools that was already installed on most of the Jubilee machines. Um, Other things were measured, such as carbon carbon dioxide levels. So this was made by Keith Brown from Boston University, who collected data using a very new probe attached to a Raspberry Pi. And this is a little graph of the levels of carbon dioxide in the lab as we gathered for the first discussion session. Um, And then also software things were made. So this was made by Madeline Wolf, who started making a Science Jubilee GUI. Um, and we are eagerly awaiting its worldwide release. So Madeline, let us know when the GUI is ready to be launched. But yes, people made more things. I'm not gonna go over everything that people made, but there was like a really good range of things that people were able to put together in very limited sessions. I think we had 4 sessions total of a couple hours over 2 days. Okay, and so now I'm gonna transition to the discussions. And so we there were 4 different discussions, each moderated, which each with a kind of prompt. And then we would split into 6 groups, and every group was assigned like a lead and a scribe. So a lot of notes were taken on each of these conversations, and the summaries I will give here are based on these notes. So I wasn't there for all the conversations. I just like made a summary of what people talked about. So first conversations we had was on establishing common form factors to experiments. So how can we design hardware form factors that balance standardization with flexibility to support open scalable lab automation? And I think the quote here from this group might resonate with people. This group talked about the difficulty of standardizing communication between tools, even with a single platform like the Jubilee. Yeah, in their words, lots of heterogeneity of systems and tool chains. So how do we try to bring all these different like pieces of hardware and software together that aren't necessarily made to talk to one another? And so so those are some of the takeaways. Modular interoperability is more important than one size fits all standardization. Form factors should account for non-planar motion, continuous experiments, and multi-axis fabrication. And the community currently leans on industrial standards, but desires open source variants that are easier to adapt and cheaper to access. And so this theme of especially modular interoperability comes back in almost all of the discussions or many of the discussions. So that was kind of a big takeaway of that conversations and how do we build for that. Nobody came with solutions, but there were a lot of ideas. Another conversation that we had was on documentation. And so documentation is a challenge. How can it takes time outside of the actual development of software or hardware or community building. And so how can we improve the creation, accessibility, and sustainability of documentation to support reproducibility and collaboration? And so these were some of the takeaways. So people talked about how templates and standards are important. So some group mentioned IKEA styled how-tos or shadow boards formats that help newcomers contribute, but also see what's missing. So shadow boards being the kind of like tool boards in machine shops or just workshops, where you like put all the tools and you can see what goes where and what is missing. Um, some groups talk about maybe large language models can help, perhaps, by sort of taking care of some of the maybe grunt work of documentation and then humans coming in and refining, maybe. We did do a live, I remember in my group, we did try to create a figure using Claude for documentation, and it was pretty bad. Was So, not perfect for everything, obviously. Another point that was made was that documentation should be multimodal, so not just text, but also images, videos, that sort of goes without saying, and then audience aware. So who are you talking to, and do you need different documentation for um, different levels of expertise or just backgrounds? And then people also talked about an interesting point, which is that the best documentation sometimes is designed, not written, so integrated into the build of the systems itself. Um, so this is an example quote of that idea. So sometimes simpler designs reduce the need for detailed and extensive documentation, and that might actually contribute to support a culture of fluency in the community where you build a simple machine that can still do things and make you feel confident to then take on more custom applications or more complex designs. And I think this conversation was very sort of unfolded in the context of the Jubilee, which is open source and relatively easy to assemble. But then again, that really depends on your background in machine building. um, so is there a way we can make even simpler designs for newcomers? The other discussion was on lab orchestration. So how do we coordinate complex workflows that involve automated handling of multiple lab samples and instruments in an open, scalable, and a robust way? And so some of the takeaways, again, modularity is non-negotiable. Orchestration must support plug-and-play workflows and flexible handoffs. Loose orchestration is more scalable than very tight centralized models. The human in the loop design is crucial, which again, I think we had a good sort of overview of that in the lab orchestration video that I showed earlier, where Tim had to manually come and screw the little bottle. Or sometimes you just want an expert or a human to come in and analyze data and make decisions to decide next steps. So how do we also scale not just the tech, but also make sure that humans can intervene at the important moment and that they know when to intervene. And then finally, simplicity is preferable to full automation. And then finally, we talked about building community, and I'm going to spend a little more time unpacking the takeaways of that discussion, since this is kind of a key point in this discussion today. So the prompt was, what structures and practices best support the open source lab automation community? And so when we talk about community, the first question perhaps is, how do we get together? And so people talked about how online and informal groups are really important. I think this one is a really great example. But also in the context of that conversation, people said that one issue sometimes is that there's like a tension between the kind of very generative discussion that you can have in informal groups versus the more organized and structured discussions or gatherings that can then lead to documentation and community standards um, and these kind of like community infrastructures for other people. Um, Another way that people can get together is obviously conferences, although people did talk about how big conferences aren't necessarily a great way to build community. They're less a discussion platform and more of a stage. You kind of like go there and share research. There's like a performance aspect. And so people discuss how small, more community-driven conferences or gatherings um, are better ways to build community, and also oftentimes force you to maybe get more involved and collaborate with others. Um, Other ways to get together are learning together through learning and courses. So people discuss micro courses, the Accelerate Consortium's micro courses, which are online and free. And people also discuss the possibility of maybe developing a kind of course that wouldn't just teach skills sort of like individually to people, but also um, sort of get people to contribute to the community. So a kind of course that would have broader design objectives and therefore open the door for later contributions, such as a course that, for instance, uh, forces people to learn by contributing to a very big collective project, and that through participating, you kind of not only build skill but also contribute. Um, so kind of have a more sort of perennial learning model. Um, And then this sort of segues into the theme of knowledge and how communities build and share knowledge. And so, you know, people need to be able to share knowledge to the new people joining the community. So this means there should be clear on-ramps to get people into the community, but also off-ramps so that people who have knowledge and or older members leaving the community do not create a void. And so how do we structure that? Is there like a kind of database? Is there some kind of like centralized or like knowledge hub that people can keep um, contributing to? And all of these parts are of course not separated, but they're part of an organic whole. So a lot of these themes sort of flow into one another. And sort of one theme that came out of reading through all the notes from this discussion is that communities really grow out of the soil of shared interest, but also of shared knowledge and time spent together, which is maybe something that is everybody is sort of short on, that isn't super well funded. How do we get to just get together and spend time together? And so I want to maybe conclude this brief overview of the workshop with an idea that maybe will sound provocative, but bear with me. So, what if lab automation disappeared? And this idea was actually inspired by one of the group discussions going over some of the discussion notes. And this group was specifically talking of self-driving labs. And they were saying that self-driving labs should disappear. So, not specifically talking about, or not talking about lab automation per se, but SDLs or self-driving labs specifically. And I think this conversation was unfolding in the context of all the hype surrounding self-driving labs and the fact that they get a lot of attention and grant money, and how they should in fact just disappear. Because the idea is that, in fact, if self-driving labs really work, that would mean that the whole infrastructure of software, hardware, humans would be so well integrated that the very idea of self-driving labs would become obsolete, would like recede in the background. And I kind of want to flip this idea on its head and suggest that lab automation too, in a sense, should disappear if the tools become so good that they're just sort of part of any science lab de facto infrastructure, just like we might take for granted that any science lab would have like measuring instruments and computers and benches, and then they would also have um, automated system to carry out entire experiments or part of experiments. And so in this vision, this vision relies a lot on the idea of tools getting better. But I want to propose that for tools to get better and even more integrated in the infrastructure, what is required first and foremost are people, and more importantly, people who collaborate together on machines, because especially for open source lab automation, there's always going to be a need for setting things up, optimizing and fine-tuning workflows, human in the loop design, people intervening, calibration, maintenance, and repair. And those are the things that need to become part of the infrastructure as well. So what I'm suggesting is that there's a need to invest in the tools, but also in the culture and in the lab culture in particular, where scientists work with, of course, other scientists, but also engineers to make this vision of lab automation sort of come true or disappear. And so let's fund a pizza. Let's value the time spent onboarding a newcomer. Let's prioritize the spaces, physical, digital, that make collaboration possible and people being able to meet one another and share ideas and share resources and learn and make together. And so, yes, community is the infrastructure of lab automation. So let's build accordingly. So that's it for me. This is the recap of the workshop. And if people have questions or comments, I'd be happy to talk more.
All right, let's give a round of applause. Thank you, Gabrielle. It's great. I'll stop the recording there, and then yeah, we can have some time for discussion. All right.